Welcome back. Time for the next one of our deep dive panel discussions, industry-wide data sharing and governance. As you heard Tom and Neil discuss, data sharing is one of the most critical barriers to overcome in successful AI deployment. Many people think you can just go out and implement AI solutions, but without the data, it won't work. And often a single utility, even a large one, won't have enough data on its own. So, to dive into how we can better collect and share that data across the industry and implement solutions to bring algorithms to the data, I am very excited to turn it over to Cheryl Ingstad, former director of AI and the Technology Office for the US Department of Energy. Cheryl's going to lead the conversation with leaders from Brookhaven National Lab, North Carolina Electric Membership Cooperative, Duke University, and Via Science. Cheryl?
Well, thank you, Christine, for such a wonderful introduction. Really excited about our panel today. And myself having experience in big data analytics projects, and then also as the former director of AI and technology at the Department of Energy, I experienced firsthand, number one, the tremendous desire of people at all levels of the organization, whether they were in operations or in the research and the R&D area. They all wanted to share their data, and they all had a fundamental understanding that they could derive so many more insights if they could only share that data, and how much more valuable the data would be, their insights, and how much more efficient they would be as well if they could only combine data sets with other organizations. And then number two is that all the barriers came. So, the permissions, the applications agreements, the talent, getting the right talent on the project, and then also the data wrangling, and of course, security. So we will talk about all of these subjects today, and so we are fortunate to have a panel with experts from academia, experts from industry, and I'm excited to kick off our session right now with our first panelist, who's Trey Gowdy. And Trey is the program coordinator for Energy Data Analytics Lab at Duke University. Trey supports a portfolio of research projects, including open energy data. He has worked in state government clean energy and in higher education sustainability programs, focusing on issues from solar power to energy efficiency. So with that, over to you, Trey.
Thank you so much for that introduction, Cheryl. Hello, everybody. Trey Gowdy, Duke University Energy Data Analytics Lab. And today I'll be presenting an analysis of the open energy data landscape. So this is research that we've done to understand what open energy data are available and where there may be gaps. So first, we want to talk about the value of open data itself. Open data can provide greater transparency and innovation across the public and private sectors. This can include open weather data, geospatial data, as well as real estate data for improved decision-making for the public and private sectors. Specifically for open energy data are present in many forms. This can include maps of energy infrastructure, statistical data of energy supply mixes or energy consumption statistics, as well as qualitative features such as the presence of certain energy technologies. Energy data can also be transformative, from informing policymakers or businesses to the potential output of a solar installation, to transformative for consumers for using timely crowdsourced data to understand differences in gas prices in different local gas stations, or potentially the availability of gas at stations such as earlier this spring along the East Coast when there were some outages at gas stations. They can also be transformative for researchers to understand the environmental impacts of the energy system. However, we've identified that, our research has identified that there is potentially gaps in availability and accessibility of energy data across the energy system, and this can limit innovation. And as we move to the next slide, we want to show that what we're doing here is looking at a system-wide perspective of the energy data landscape. Previous research has focused on certain subsectors of energy data, including energy efficiency or the building energy consumption sector. And what we're looking at is a systems-wide perspective from primary energy on the left side of your screen, electricity sector, end use consumption data, as well as system-wide considerations from prices, policy, and efficiency. And on the next slide, we want to note that we provided we conducted a systematic review of the open energy landscape. And on the next slide, we'll see that we researched over 180 search terms, plus additional input from experts to create an inventory of over 400 entered data sets, as well as energy data discoverability services. And so on the next slide, we want to provide a sense of what we found at a high level. And although intuitive, it's telling. We found that there are simply more data higher up the energy data value chain, from understanding the potential output of solar systems as well as wind turbines, greater data on utility scale generation infrastructure, such as power plant information. However, there are more limited data as we get later down the energy value chain, such as less available data as distributed generation is seen on the grid from rooftop solar, and as well as there's a lack of data on personal energy storage systems. There's also less available data in terms of granular consumption and end use data, as well as limited data on local distribution networks. And on the next slide, we want to provide, in the following 3 slides, provide 3 examples of what types of data we found. So on energy potential and resources, here's an example from the World Bank of a data platform that allows essentially near global coverage of the ability to analyze the potential output of a solar installation anywhere on the globe. And on the next slide, we'll see a platform from one of our partner organizations, the World Resources Institute, that aggregated data on utility power plants, providing information on the capacity of those power plants, as well as the fuels and technologies within those. And then the third example on the next slide is a visualization of transmission infrastructure across the globe from OpenStreetMap data, as well as predicted distribution infrastructure for local distribution networks. And so on the next slide, we'll see this is essentially a snapshot of our research as a whole. And on the left side of your screen, you'll see descriptions of the type of data providing organizations, from government organizations, universities and academia, nonprofit organizations, and others, as well as from the left to the right, you'll see the energy value chain from resources to electricity generation, the fuel sector, as well as some other aspects. And the key to this slide is there is, from our research, variability that we did find across the energy system, but also in the types of data that are provided by certain types of organizations. So on the next slide, we'll note that we found the most abundant data from national level government agencies, in particular on energy resources, fuel sector, electricity generation, as well as statistics on energy consumption. On the next slide, we'll show that there's substantial data from national labs, or the equivalent outside of the US, on energy resource potential. For example, National Renewable Energy Laboratories Renewable Energy Atlas. And on the next slide, we'll share that we identified some interesting data from academia on end-use consumption, and in particular, open models on sample data for non-intrusive load monitoring. And on this final example slide here, we'll note a substantial amount of data from non-governmental and intergovernmental organizations, such as the United Nations, World Bank, International Energy Agency, and others, on consumption statistics, but also generation statistics at a macro scale. And on the next slide, we just talked about all of the data that we found, but wanted to highlight some of the limitations and why we think those are the case. So in the next slides here, we'll show 4 examples of why, back to the previous slide if we could. In the next 4 slides, we'll show examples of what the potential reasons are for these gaps in the open energy data landscape. So first, the distributed nature of the data itself. So again, rooftop energy generation, as well as just other aspects of the energy system that are more distributed and smaller across geographies. But there are potential solutions to this. Additional research from our group analyzed remote sensing methods using machine learning to potentially overcome some of these. And for example, the image on the top left shows the potential to use machine learning and satellite imagery to identify solar installations on top of roofs, as well as the top right image provides the ability to use satellite imagery and remote sensing to see where vegetation may be interacting with energy infrastructure. And then finally, on the bottom right slide, or bottom right image, we identified that there are opportunities to use machine learning and remote sensing to estimate building energy consumption. And on the next slide, we'll note that the second potential reason for limited data in certain areas are security concerns as well as privacy limitations. There are certainly certain types of data that are critical energy infrastructure that may have resolution limitations, as well as personal energy consumption will have privacy limitations as well. However, to overcome this, we recommend that there may be opportunities to create synthetic or anonymized data to potentially use these data while still addressing potential privacy concerns. On the next slide, the third potential reason for gaps in aspects of the open energy data landscape are proprietary concerns. There's certainly business considerations, but also it takes time and financial resources to create and manage data itself. And there may be opportunities through events like this to create collaborations to potentially overcome some of those hurdles. And the final limitation that we note is on the following slide is the challenges with interoperability. And we recommend identifying opportunities to adopt consistent data standards such as FAIR data standards, which will following the principles of findability, accessibility, interoperability, and reusability. And hopefully those keeping consistent data standards in mind will allow for data to be interoperable across organizations, as well as recognizing that there are potential limitations as data are collected through different geographies or different topics. And so in closing, on the following slide, just want to encourage you to check out our link at the top, bit.ly/energy data list, where we'll be providing our full list of over 400 data sets that we identified, as well as thank our large collaborative team for their help on this research, as well as support from the National Science Foundation. Thanks so much, and back to you, Cheryl.
Well, thank you. So interesting. I already have a few questions at the end that waiting for you. So thank you for that really informative introduction to the subject. Karsten Claes is next. So Karsten is the director of the Computational Science Initiative, CSI, at Brookhaven National Laboratory, and she leads BNL's computational science and mathematics R&D portfolio, reaching from leading-edge research to operational infrastructure provision. The CSI focuses on novel hardware, AI, and applied mathematics for computational modeling and quantum information science. So with that, I'm really looking forward to your presentation. Over to you, Karsten.
Thank you very much, Cheryl. And if my slides come up, there we go. You can see a little picture of some of the activities that are going on in CSI. And I'm going to talk about how we are using AI to bring real-time analytics to the power grid and what data challenges we encountered and how, as a national lab, we were able to address some of those. So when we got started, one of the first things was really make use of our local capabilities on site. We were very fortunate at Brookhaven National Lab that we had an arrangement with one of the power companies that used our land to put a large solar farm on our property. In return for that, we got a 1 megawatt solar array that we could use for our own research as well. So we were able to instrument it, and that was really the starting point for a lot of the work that we are doing, and we have been very happy to collaborate with others around this. The first thing that we did was obviously solar energy forecasting. We have a researcher at Brookhaven Lab in atmospheric science, and so they have a lot of experience in measuring and monitoring cloud coverage and solar radiation. So all of this came into play, and we used our AI capability to start forecasting what kind of load the solar could produce both in short-term and long-term perspective. And that worked out really well. We could show that algorithms were more accurate in what they could forecast and were pretty good at doing that so that they could be used by a company to use this to manage their solar energy portfolio. But we wanted to go further, and so we started to also build our own infrastructure. As Trey said before, much of the data that is collected, in particular when it comes to consumer data, is very distributed. And the traditional model is to bring it all into a central space, and once you have it, you then start analyzing it. What we are interested in here was to say, can we make the analysis more local and more real time? And we developed a system called Analysis on the Wire, which basically uses the networking capabilities that are out there that are all linking us together to analyze the data as it is traveling through the internet and through the network. This has been the basis for quite a number of our solutions, and I'm going to talk a little bit about that. It's sort of a test bed that we have that creates our own data in this context and helps us with what we are doing. One of the first things, we were very lucky to get smart meter data, real data from households, obviously anonymized, for our research. And we could send this through this Analysis on the Wire framework and basically showcase how this would work if you had different users out there, consumers out there that are using their energy, and show different profiles and how we could analyze this as it's being generated. What you can see is that the AI in the colored diagram there, that the AI can really pick out different user groups from industry to single household consumers. And we were able to predict this with a very high rate of accuracy, really, what kind of load patterns to expect in these kind of scenarios based on user data that we found. And we were building in external information as well, such as weather, for example. What you see here is sort of some of the results. This is the of the analysis. What you see in red is what was actually measured in terms of consumption. The black you see here is the predictions that the AI algorithms could demonstrate. So this is also why you need at least some real data there, because you need to be able to verify your AI algorithms, not just for the training, but for verification, both for short-term and for long-term prediction in this case. We further improved this algorithm, and not just making it more accurate, but making it faster, so it could really produce real-time feedback to the users, things that are going back to the consumer to say, this is what's going back to the energy consumption, and they can then make decisions based on this. This is the load forecasting. Do I need to shed some load? Do I need to increase my production? Those kind of decisions. I wanted to finish with two examples of where we see the future going. Obviously, if you imagine that this is consumer data that flows through the internet, you then make decisions based on it from the energy company, and you need to protect this kind of data. How do you do that? And one of the things that we're looking at Brookhaven National Lab is to use quantum networking, the quantum internet, to secure the data that's being sent. And so we're working with energy companies at the moment to create, again, test scenarios for them where their data is sent, where we are then analyzing it, again, using the Analysis on the Wire framework, just in a quantum context, predicting the first. And we could show that this was very possible, but in a very secure way. So this is sort of something that we are thinking for the future. And then my research project is then looking really at state estimation and building on the capabilities and the data that we've had, taking it into a wider space, think about how can we forecast this, how can we detect what the state is, not just of the network itself, but really looking at also at influencing factors from the outside. And this is quite nice because those are usually data that are openly accessible and that anyone can get access to and integrate into their application. Looking at wind, looking at solar energy, then obviously the more protected demand data in real time. Bringing all of that and then making state estimations. And this is just a little overview of the type of research that we do and the type of data that we need for that. Some of the data, as I said, is relatively easy to come by. Others is very difficult, as Trey had outlined. And in particular, the data that's generated by consumers is the part that is very important for many of the applications, but is difficult to get to. And with that, I'm turning this back to Gerald.
Wow, well, that was really fascinating, Karsten. Thank you. And so interesting, too, that you brought up the topic of quantum for security. I'm sure we'll return to that. And just to remind the audience, I'm developing some questions, of course, listening to these interesting presentations, and we really want to see what your questions are as well. So please feel free to submit them throughout, and then at the end, we'll go through them and look forward to raising your questions to this very, very interesting and varied panel. And with that, we've had now 2 views from academia, from Duke University and Brookhaven. And now we get a perspective from someone who's in the industry. That's Chris Van Lokeren. He's the Senior Vice President and the CIO at North Carolina's Electric Cooperatives. He works closely with the cooperatives' technology leaders to implement a strategic approach to IT and data management and to advance the work of cooperatives in the energy industry. He has previously served in executive positions in asset and data management at Fidelity Investments. So welcome to you, Chris, and over to you now. Let's see. Chris, I think we might be having a technical difficulty there. It looks like we got you now, I think. Yeah. We can hear you now.
Everything was great for the first 20 minutes, of course. Well, thank you, Cheryl, for that nice introduction. My name is Chris Van Lokeren. I'm the Chief Information Officer at North Carolina Electric Cooperatives. And I think today I really want to kind of talk about a little bit of the first 2 speakers, how we put some of this into practice at the cooperatives. I think the first thing I'd like to say is that cooperatives feel like use of analytics is really going to help us fight above our weight. We're generally pretty organizations that we don't have dedicated staff to do a lot of data analytics. So what we feel like analytics is really going to help us scale and do things better in the future. And so we talk about it as a centralized data analytics centers of excellence. And we think that we can create more value as we deliver solutions for our members using high quality data sets that are shared. And we've created this model to try and show the circular nature of, we have our distribution members who have a lot of tools and want to maybe potentially do analytics on their own. But we also potentially could do it from a DNT or from a statewide organization as well, and create scalable use cases that can be delivered to multiple members. And we feel like that's a way that we'll be able to make data analytics and AI work for the cooperatives in North Carolina. And then, as we build more and more use cases, we can get ideas on new use cases and new models. And then using AI to train the algorithms and make them better in the long term is certainly something that we're very excited about doing in the future. As we built our data analytics centers of excellence, we kind of focused on 5 building blocks. I think people is always really important. We do need some staff to make this happen. I've kind of used the example. I think not sure how many people know the state of North Carolina, but somewhere in the rural eastern part of North Carolina, it's probably pretty hard to hire data scientists. We feel, in Raleigh, which is where NCMC is based, we can hire data scientists and share that capability with our members. And so we need these individuals to help us be ready to deliver this to our members. And then a process. I kind of talked a little bit about it on the last page, but how do we source and organize and prioritize our use case and manage and secure our data, which Kirsten mentioned, and create some data governance around that. And I'll get to that a little bit more on a subsequent slide. And then having the data and the technology, the business and technical requirements, gathering and creating scalable technology infrastructure and applications. That really means the cloud. I think most of this is going to live in the cloud. It doesn't really make a lot of sense to put this data on-prem where you can avoid it. Service and program management is just to ensure that we have a plan to track and measure the value of our data analytics endeavors, and that the solutions create the benefits that we anticipate, and that we monitor and improve those models and those benefits and products and services in the long term. And then we are a member-owned organization, so we need to engage with our members and various other NCMC stakeholders to solicit feedback and inform our stakeholders on progress. And if we do this stuff, do data analytics, we do AI, it doesn't generate value, then what's the point? So we're really to create some KPIs and measure that in the long run. So, so I've titled this slide before. What are we trying to build? So, the members in NCMC are different organizations. So we have a little bit more challenge than maybe some IOUs or some other people on this call may have today. As far as the distribution member, while they're an owner of the G&T, they are separate organizations. So we've had to create this governance committee with folks from NCMC and the distribution side to help us inform how to build out this platform. And the platform we see is NCMC data, weather, load data from our balance from the balancing areas that we operate in, and then marrying that data with distribution member data. And Kirsten touched on it. The value of the AMI data is really what we're trying to go after there. We feel like we've got virtually 100% AMI meters across the state from the rural cooperatives in the state of North Carolina, and so there's a lot of data that's sitting there that really needs to be extracted and try and get a lot more value out of. We want to make this platform flexible. So if a member would like to run their own analytics, kind of do it themselves, we'll make this platform available to them. That they can do their own analytics with whatever tool they'd like. And as I said before, that us NCMC providing that the staff and the folks to is really what's going to allow this platform to scale and really create scalable solutions that we can just run every day, week, month, hour, minute for our members. And so we're really excited about where this is headed. And then happy accident. I think Mr. Siebel mentioned in the last presentation about starting small. So I thought this wasn't planned, so I'll take them when I can get them. But he had mentioned starting out with some small use cases. So we have a use case around coincident peak, and just really not to get too much in the details here, but you see we have a bunch of on-prem data stores on the left here, and can we extract that data, put it in a better spot? As I at the cloud and create a use case with a UI that our members can access, so they can get more data for their coincident peak and where they are contributing to the coincident peak for overall NCMC. We use SAS as our analytics engine today, and we'll probably keep that on-prem. But we'll put all this data in a SQL server in an Azure cloud, and and create the analytics, and then soon AI that'll help instantiate use cases and make things more available to our members and to NCMC staff as well. So we're excited about this. We are small. Hopefully, this is sort of more of some practical use cases that make sense to many of you, as far as what you can do sort of on your own, and to try and make analytics reality for your organization. So with that, back to you, Cheryl, and thank you everybody for your time and attention today. Thanks.
Great. Well, thank you. So interesting, and nice to see the practical application as well. So interested in reading more of the questions that come through for the audience there. And now I'd like to introduce Colin. Colin Gowden is the CEO and founder of VIA, a company that specializes in bringing AI solutions to the energy industry. His company has developed a differentiated, patented software platform that enables AI applications while maintaining the highest levels of data privacy and security. VIA has won many industry awards, and Colin has a long history as a founder of successful technology companies. So looking forward to your presentation. Over to you.
Thank you very much, Cheryl. Thanks for taking the time, and it's a pleasure to be here. Really appreciate the opportunity to speak with everyone. First and foremost, I should start by saying, our commitment at VIA is really mission-driven. Our commitment is around trying to create a world that has cleaner, safer, more equitable communities. And digital collaboration, digital technologies, AI, data, all of that is in service of creating those cleaner, safer, more equitable communities. That, for all the reasons we just heard about, is becoming harder and harder in a world that's more distributed. I think Trey talked a little bit about this, how as you can kind of see in this graphic, there's more distributed generation, there's more distributed consumption. That's a harder world to interact in. Karsten also alluded to that, sort of thinking about solar and how that's impacting the world. And Chris also mentioned this, that this is a struggle, and especially in a world where you may not have access to all the analytical resources. How do you learn from the data that's available to you? And essentially, we're trying to solve that issue. One of the big things that we kind of took away is that, actually, could you go to the next slide, please? Let's see. Terrific. Is that even within the world of power, there's always a need for more data. AI, I don't think people use this term, but we always think AI is greedy. It's whether that's image analysis or smart meter data, you always need more of it than you ever think you could imagine. You always need more than anyone has. And Chris used that. I heard Christine and Cheryl and Chris and others sort of talk about this, which is no matter what your sample size is, any specific utility or any specific company always has less than required to train really robust internet models. And so, there's a need for collaboration. I think that all of that's been made clear. One of the issues is that we think that the old way, or the traditional way of essentially, let's aggregate all the data, let's send it to an analyst or send it to analysis, that has a lot of issues. It's broken, and we've heard people kind of talk about these individually. So some of the issues relate to data privacy. Whether you're in Europe and you have GDPR, California and CCPA, Virginia has a new data privacy rule. Or even within individual organizations, there's a need to keep data private, and that can be a barrier to sending data to others to be analyzed. The multiple data sources. Actually, I heard Trey kind of talk about use the word data interoperability. So anytime you have multiple sources, you have an interoperability kind of issue. And that's one I think, man, I'm going to adopt that term because that's a better term that, that actually gets to the source of the issue. So we see that as kind of a big barrier when you kind of try to combine data from multiple places. And I'm sure, Chris, I can't empathize enough with it. I can't imagine that challenge that you've had trying to bring all that data together across the cooperatives. And then the other is just sort of the cyber risks. We live in a world where cybersecurity is probably one of the most highest profile issues at the CEO and board level at many companies. We live in fear of that. 2021 has been a big year in this world for this, and I think part of the reason, Karsten, I can see you moving to quantum is because of those cyber risks, right? Is to kind of avoid these issues, and so. We see these as barriers, and essentially thought, well, there is kind of another way to approach this to deal with these, and that's essentially send the code to the data, right? Kind of reverse the flow. In a world where data is growing exponentially and getting bigger and bigger, and the algorithms to run, to be the AI is actually getting smarter and smaller. Why not send that code to wherever the data is, and in between? Actually manage the flow so that you can make sure you address the big issues related to privacy and multiple formats of data and security. So some of the things that we essentially focus on. Could you go to the next slide, please? So one of the key elements is around query level access control. So more than just sort of sending any query to the data. We have a mechanism that uses smart contracts, or basically an electronic mechanism that controls at a query level. Is this not just who are you, but are you allowed to ask this specific question of the data? Is that permitted? And what results are you allowed to see back? Aggregated results, individual level results, or other, a bigger set of results, and control the level at which queries and results are exchanged. The other piece is the data wrangling. I've heard that on our talk today. Essentially providing AI tools to enable faster data wrangling. We'll talk a little bit about that in a second, but basically that, solving for that problem helps speed up get over some of the barriers in aggregating data and data analysis. And then the last is something we've tried to solve for is, rather than data privacy rules, if you're sending code to the data, wherever that code is going to run, you're going to need cybersecurity. So you change a data privacy issue into a cybersecurity issue. One of the things VIA has done is gone out and started to work with the Department of Defense. And with the Department of Defense, we've now just achieved one of the highest levels of cybersecurity accreditation and available. It allows us to work with top secret level information, and every commercial company can benefit from that as well. So this essentially provides a platform where organizations, multiple companies, multiple players can collaborate using our platform, and they can learn, have models or applications or algorithms built by us. But we're open about that and know that, if you look at some of the work that Karsten is doing at Brookhaven, or Trey, some of the work that you're, at Duke, other people are going to have a lot of applications and invest in AI. And so making the platform available for others to be able to bring that AI to their data is kind of a top priority. So the same platform works across both kinds of areas. And the last couple of things I'll wrap up with is, a little screenshot here that shows, there is an opportunity, as a data owner, maybe I'm one of the cooperatives in Chris's group. I have a simple way of being able to essentially use AI to take a file and be able to transform it into a standardized AI-ready format for data analysis, particularly around AI, or particularly around AMI data. And the other is once it's on the platform. Sorry, next slide, please. There is a library of models that are already pre-built and pre-developed that can be deployed to be used on those data sets. So with a standardized data format, by taking that off the hands of the utility of having to transform their data and putting it in a standardized format, these model, we always say whatever format your data is in is always the wrong one for whatever analysis you're trying to run. Here, we're making it easy by saying these models are pre-built to work with a certain format, and you don't have to do a lot of data changes in order to make them work. There's some common ones here: load forecasting, non-intrusive load monitoring, anomaly detection. The number of models are growing pretty frequently, so we have updates added monthly, and working with a wide variety of organizations to do that. So that provides a little overview of VIA and what we've been doing in the space, and look forward to having the discussion today. Back to you, Cheryl.
Oh, well, thank you. So interesting, and to see what the real commercially viable solutions are, and that you have contracts, and it's active in the real world. So congratulations, fantastic. So I'd like to start off with a question for Trey. Trey, really appreciate your presentation and the kind of the data that you're getting access to. And I had a couple questions. You mentioned that there was limited data for rooftop solar. And we know when we look at what, say, Department of Energy is doing with investments in solar and also private equity, venture capital, that this is going to be a high growth area for the next several years. So you were talking about limited data, and also the fact that it's hard to get at the residential power storage. So if there's residential, they have batteries, kind of on an individual level, it's hard to get at that data. Are there any solutions that you might recommend? I know you talked about remote sensing, IoT, other ways to get at that data.
Right. I think no identified solution on the residential storage component, but certainly for rooftop solar, the ability to use satellite imagery and pair that with machine learning to automatically identify that work has been taking place at a number of organizations. And so I think that's an area where there's potentially more opportunity to identify those types of infrastructure, especially as we go into a more distributed future. But sort of the traditional model of utility and energy infrastructure reporting, that model does not necessarily capture distributed energy generation.
Okay, very, very interesting. And then you were talking about synthetic data and how that might be part of the solution to the fact that there are, privacy issues when you are trying to collect this information on an individual level. Can you just give some more examples of how that synthetic data is developed, and then how it also might be shared?
Sure. So we identified an example of data for the power grid of these to essentially, in some ways, mimic the structure of the grid, but not to the exact specifics. And that's one potential way to test out different scenarios. There's a group of researchers at Texas A&M that have done some work on this. So creating data sets that are similar, where you can answer some simple questions or particularly interesting questions that you can use synthetic data for. That's a potential area where maybe you don't need the exact specifics, but something that is statistically similar may address some of those concerns.
Okay, terrific. Well, thank you. And then another question here for Chris. EPRI, Duke, Department of Energy, and others have stated that they're willing to share data. How can we convince other organizations to share data as well?
Yeah. Yeah, I think I'm in that now. Thanks, Cheryl, for the question. Hopefully you guys can hear me. Anyway, working with our members has been a bit of a struggle to get access to their AMI data. And we got a lot of our members that have said yes, but some have said no. And it's really persistence on my part and a lot of the folks that work with me's part, and getting them to say yes. I think that there, I think Trey and Colin have kind of hit on it. This whole cybersecurity and what's the value of this data and is tough. And obviously keeping the data in an on-prem database with only access to people at Cooperative X gives a relative amount of safety, and making that data available to others has been a difficult value proposition to describe. And we have made the case, and we've got a lot of the access, but it's been a difficult journey for us to get as many of our members engaged as we have so far. But I think what we try to do is, with the ones that do share, is to try and create the use cases and show that value to the ones that won't. And then I think by doing that, you can hopefully get more people in the boat with you and move along on this topic. So, good question. Thanks, Cheryl.
Okay, you bet. Yeah, thank you for that great response. And then a question for you, Kirsten. I kind of let foreshadow the coming of this question on quantum for security. So I know that Department of Energy, and I was really pleased to see that Congress has allocated money for quantum as well. How close are we here to being able to demonstrate its value for security? I know you were talking about already going down that route with your research.
Yeah, I think we're still quite a few years out. So there's obviously quantum key distribution that you can use already to protect the data, to encrypt it. But that is not the ultimate form of security. The ultimate form really requires an under quantum network. Now we have a demonstrator on Long Island where we've been able to show this kind of interaction and distribution over 153 kilometers. But going much further, it's really that's where the challenge is. There's a lot of research going on in that area to take this further. So it's probably still a decade off until we can really deploy that. But it's something to keep an eye on and develop the use cases and make sure that once the quantum internet is there, it can solve and support these kind of applications.
Okay, terrific. Well, I've already taken a few questions from the audience, and I have one more here. Question for you, Karsten. In some cases, people have been able to back out original training data from interacting with ML models. How can we ensure the security of the original training data when using federated learning?
Yeah, so again, the Department of Energy actually has research in this area. It's called Privacy Preserving AI, and we have one of those projects. And what it looks at is encrypting the data, encrypting the model, and then you can transfer it. Say you can run it, but it's basically no one else can break in and extract the data back out of it. Only the original user. That's the only way. If you open up your data to the general public, then there is a chance, if it isn't very, very well anonymized, that they could extract certain information out of it again. And I think that is this kind of concern is one of the factors why people might not share that data. I think another one is that people fear that you might discover something in their data that they haven't discovered themselves, and that's embarrassing.
Yeah, good point. Very good point. Well, and on that note, speaking about security, a question for you, Colin. It sounds like you're working with such large data sets, and you mentioned organizations with classified data, such as the Defense Department. how do you ensure the security of the data and of the algorithms?
Very carefully. Uh, so there's a lot. So following a little bit on what Kirsten said, and I think one is math. So math has been math has been around for thousands of years, but actually the math is getting better and better in areas like cryptography and being able to analyze data and maintain privacy. So there are a lot of techniques: differential privacy, k-anonymity, homomorphic encryption. There's like a set of tools that are able to allow the analysis of data and keep it private and secure. What we're doing at VIA is essentially saying those tools all provide a specific level of data privacy and protection, and you need a simple way. Most people are not math people, as it turns out. Chris, you talked a little bit about that, how the cooperatives, it's hard to find people, right, who have, maybe data science or Python skills, never mind homomorphic encryption skills, right? So how do you find, so basically making it simple that there's a switch, there's a lever, there's a radio button that you push and say, this is what I want, and it will automatically kind of, provide that level of data protection. The other is, we touched on this a little bit earlier, is, we've seen energy companies that have their data privacy policies like 1,000 pages. Literally, it's that says here's all the rules about keeping your data private. I think that's going to be hard for a lot of analysts to read or enforce or even adhere or sign at any point. I think the idea of moving the code to the data keeps the data. You don't have a data transfer issue, so you're not taking possession. When you do that, then there's a cybersecurity piece, which is how do I make sure that AI is not doing anything malicious? How do I make sure it's containerized? How do I make sure it's meeting cybersecurity standards? The good news is the DoD has made public a lot of these standards, and so our accreditation sort of meets a number of those. The standards are pretty high, where in fact, they will test your code or containers, in our case, every few hours. So it's not a 6 monthly pen test. It's like literally multiple times a day. And if you have an issue, you have 12 hours to fix that issue. And so that level of cybersecurity means, it's nothing is ever perfect, but it's like better than the alternative of, taking, of not having or sort of 6 monthly tests. So we see that as kind of a big way of dealing with some of the issues.
Okay, and another question for you, Colin. The topic for today is industry-wide data sharing and governance. And that's so critical that we're sharing, but according to rules that we all agree to, and that those standards are enforced. And I was wondering if you could talk a little bit about how important standards are because of the data wrangling issue. And you mentioned data wrangling, or maybe the new term, data interoperability, a little softer term there. But the criticality of standards, and if you could touch on IoT data feeds, now that we really have a plethora of sensing devices out there, all running on different protocols, different manufacturers, and we wonder, can we trust these, and will they actually have attacks that are built into them that then get into our data sets and affect our algorithms? So anyways, big, broad question there for you.
No, it's a great question. So first, I think, as Trey was talking about, open data is great. Data standards are great. If everybody could agree to a single standard and stick to it, then that would be fabulous, right? We should all that would be great. The issue is that, people don't agree all the time. And, Cheryl, you just said IoT is proliferating. The number of new devices and new data formats is moving faster than any single standard is going to be able to be adopted. And so we think that, if you could get standards and everyone to agree, then that's like an ideal scenario. The truth, in the alternative is can you use technologies like AI to be able to take formats of data that are different and put them into a standardized kind of view? And that's kind of what we'd look at. And the analogy I might use is, your cell phone, every time you take a photo, the little image comes up and you'll see a little red circle that highlights a person and says, oh, this is the person's face, right? There's some image recognition. They didn't say, camera makers didn't say, all people need to look alike. We need to standardize on what the human face looks like in order to make sure this little red circle comes up to highlight a person. No, we kind of said, whether you're a friend or stranger, night or day, crowd or alone, the enough training allowed you to identify this is a person's face, and that's what I'm going to focus in on. Basically, that same approach can be used in data to say, I haven't seen this data set before. I haven't seen this format before. I haven't seen this context before. But I'm able to say, that looks like it's a time date stamp. That looks like that's a kVA or voltage or amperage, or that looks like it's a reading, and then pull it into the right kind of format and help with that wrangling. So we think actually in a lot of ways the energy data is easier set than what we do with human faces. So hopefully that's and be happy to, for people who are interested, happy to run demos and show like what that looks like on their own data to kind of prove that point.
Wow, well, fantastic. Well, we've covered data sharing, the governance, standards, security, even quantum. So very exciting. And I know we're down to the last couple of minutes. Are there any final thoughts that any of the panelists would like to add?
I think one of the topics that's coming up more from our side is also looking at potential bias in the data. When we talk about explainability of the AI results and knowing if there's any bias in the data that the user should be aware of so that they know how to interpret the results. I think that's a new requirement that's coming, and that will be very interesting. So we might not only ask people to share their data sets, but there might be a little bit of a quality standard with it as well.
Yeah, absolutely. When I was at Department of Energy, one thing we really looked at is how do we test the data sets, make sure that they're secure and clean, and what is the provenance of that data, and have they been the people who made changes to it, were they authorized, and what is basically the chain of custody for that data, and then the same for the algorithm that you would apply, and then how do you continually test that? Colin, you talked about it at the DoD that they're testing your algorithm every 3 hours. But what is for each type of data set and each type of algorithm and use case? What is the appropriate time that you should come back and do monitoring and do another test to recertify that data set and recertify that algorithm? And that is extremely critical, that we really get into a discipline of that with our AI. So with that, I really want to say thank you to all of our esteemed panelists. Thank you for joining us today. Thank you, Christine and Jeremy, for putting together such a wonderful AI summit as well. And so back over to you, Christine.
Thank you, Cheryl. Okay, so that was a great discussion. I think here there's no silver bullet to achieving wide-scale data sharing. It's about cooperation, standards and formats, overcoming privacy and cybersecurity challenges, and taking stock of best practices of early adopters. But the success stories are there, as we heard. We have demonstrated standards. We can bring these AI models to where the data is, and we can train these models. So great discussion there. All right, heading into our next break, we've got our last short video highlighting a crowdsourcing innovation challenge focused on developing machine learning for grid operations. It's called Learning to Run a Power Network with Artificial Intelligence. This is another inspiring EPRI project that's collaborating with a number of organizations across the globe. So we will see you back here for our last panel discussion at 2 p.m. Eastern, and enjoy the video.